Here we go deeper in what you need to know about cameras, windows, stretching and so on. If you don't know how gamemaker does its graphics and you haven't watched my last video, I highly recommend it for you to watch it first so you get a deeper understanding on what comes next. Pause this video, I just wait here. Alright, how is this whole video being structured? In two parts. Timestamps to skip the content. You will get some basic overview, what kind of resolutions exist and how they tie into the camera system of gamemaker. There are some weird things concerning display resolutions and I want you to understand why there is so much confusion and half-baked solutions. After that, I will introduce you to a minimal way to set up a camera system. This resolution will work just fine for a windowed or for one resolution setup. It will not scale perfectly in all monitors and you may get black bars on full screen mode. But it is an almost carefree version to use. The next video will be more programming heavy for those who want to dive deep into how you can make a pixel perfect camera. So if you want to skip it all and want to get your hands on the camera project for a pixel perfect camera, well, I won't stop you. It is now available on my Patreon page for free. No strings attached. Let's get started. The video games are being shown in a display and you may have come across the term 16:9, 4:3 or display aspect ratio. This refers to the proportional relationship between display width and height. Monitors, laptops, smartphones and widescreen TVs, for example, have different aspect ratios altogether. According to a Steam survey of May 2019, most users' resolution is a 1920 by 1080. With a whopping 60%. That is a clean 16:9 ratio with common monitors, 16 pixel width to 9 pixel height. Nice and easy to scale up and down. So far so good, but here comes the kicker. 10% use a 1366 by 768 resolution. Just to put it into perspective, 2016 36% were using the 1920 and only 25 were using the 1366. So as you can see, it is heading to a more user-friendly resolution to work with. That is good for you because you can go away from too many resolutions and most importantly away from the 1366. This resolution is terrible to work with and I'll show you why. So let's go a step back. How do you calculate the aspect ratio and why is that so important? Everyone has seen a movie or a game with black bars on the sides or sometimes on top and bottom. The device tries to fit a video or a game from one aspect ratio to another. Here you see a game that has a 4:3 ratio and now it tries to fit in a 16:9 widescreen. Let's say we have a screen of 1920 by 1080. The game's resolution is a 480 by 380. The monitor tries now to fit the game on one screen. As you can see, it is quite small. It therefore tries to multiply the video game size to fit it and remain the 1:1 pixel ratio. But now you can see that it fits 3 times and well, the fourth is cut by a lot. So this is how the black bars come into existence. Another way to circumvent it is to stretch the whole thing with an uneven multiplier where the pixels get interpolated. Interpolation is simply the method to assign a pixel color that lies between two known ones. And that is the most terrible way to do it, because the result will look like it's washed away or smeared. How can this be fixed? Your game, or rather your camera, needs to adapt to different types of screens. A quick and dirty hack is simply to make cameras with different resolutions and only use these for the window and the camera. No zooming, no full screen. It only shows the cut of the level you want to show. But the 1:1 ratio of the pixel art is there. You can go even for some funky camera sizes if you wish to. Or you define your game resolution for the camera and you cut the room to show the window resolution. These two need to be adapted to the aspect ratio of the user's monitor. Here, the camera and the window resolution can be the same, but pixel art is quite small, so you want to zoom a little bit into the room. Basically, your camera window width and height are a multiplied version of the aspect ratio in question, and this can be used for the zoom as well. And to get the display aspect ratio, you need to calculate it. Or just copy-paste these from the wiki page in the description. Remember those two most popular display resolutions used? Let's get those ratios by hand. So, we calculate first 1920 by 1080 resolution to prove a point. you simply divide both values with a prime number, like 2 and 3 and sometimes 5. No decimal rest values are allowed. So we have 1920 divided by 2, which is 960. 1080 divided by 2 is 540. Then we divide both by 2 and 2, and that is no longer possible, and then we divide it by 5, by 3, and voila, we have our 16 by 9. There's no possible way to divide it further, and we got ourselves our first aspect ratio. Let's repeat the process on 1366 by 768. Divided by 2 and what?
Nope.
683 is already a prime number. No further divisions possible. To fit this monitor, you can only have a width of 1366 or 683. So here you may see what you can do and how sometimes black bars are unavoidable to maintain a crisp and clear overall image. The aspect ratio is key here, and with it you can assign the camera properties. Hopefully that made things clear for the future. Alright, so let's go for a more practical way. How can you set up your camera so it should follow one thing? For example, this little tank here. GameMaker has you covered here already, and it's under viewports and cameras. You just have to enable it so it works in the room, but you can do that with code as well. Set it on visible, and then you have the screen. So once we, for example, restart, it should already work. As you can see, it's a little small. This is something we don't want in the end. So we do a zoom, which is proportional. So we just take the half of the width and the height of our window to be and zoom it into our cut of the level. So we just go for half values, which are like this. One sec. And we just say, okay, follow an object. These values are pretty simple. Here you just define, I don't know, let's say 100 and 100 as well. And these borders are the borders of your camera. And once your object, which is coming close to those borders, it starts scrolling downwards and upwards and so on. And the scrolling speed is for the horizontal value 100 and for the vertical 100. And this is how you set up the easiest camera you have. As you can see, it's zoomed in. The thing looks pretty decent already, but this is not what we want to do, because the scrolling is pretty choppy and you can do that manually really better. So therefore we have like this thing which we call our camera. We drop it in, it's empty, and we need to define a few things to make it work. If you have seen the tutorial video from Pixel Pop, this is quite the same, but I just do it a little bit different because sometimes different approaches can be healthy. So we define two values which are called camera show height and width, and these values are basically the camera or the cut you want to show. If we go back to the room, for example, we don't want to show the window, we just want to show the cut, which is defined by this board, as you can see here. So we go again for width, which was 480, and the height was 270. Alright, so the next thing we want to set up is our window size. So the next thing is quite crucial, because first of all we want to have our cut with those parameters, but our window to be double the size of those. So we go for window set size. This is here, and we define double values. For example, we could take those, or we just go manually and put them in here. 540. Something we need to do here is to change our application surface. Why do we have to do this? The application surface will basically be stretched to the window size, and we want the application surface to be the same size as the window. And that's why we go for a surface set surface resize and there we go for the application service because this is our main target. And here we again take those values of the window itself. And already we have a camera system in place. So the next thing we can do, but we don't have to, is to go for other and room start. And here we can do two things, which is view enable and set it to true. And view visible. And this is so what do these things mean? Basically, you need to have two things. You need to have your views enabled in order to use them, and you need to have them visible, which is the same when you do like manually here. So basically you could just disable those kind of functions and put them dynamically into the camera, and every time you start a room you have your camera which is always there, so that's why it's flagged as persistent, and you always enable them and make them visible. But you can leave them out and just put them in here every time you have a different room, but this is just a thing you can do as you please. So, and for centering we go for an alarm, go for the alarm of 0 and set it to 1, and when we get into our alarm we just want the screen to be centered. Alarm 0, and here we just put in window center. This is basically just when you open the camera, it creates this create event, does the window, and so the window is being dragged once into the middle. But then you can of course drag it into the other positions, but this is very handy to do so at the very start of the game, so it doesn't do anything strange. So the next thing we want to do is to set our camera to a specific size, which we already assigned here. So we go for camera set view size and put in our camera 0, because this is the first camera which is automatically per default being produced, so you don't have to worry about it, it's already there once the room is being initialized. And then we just go in for our camera width and our camera height, and then we don't need to use it any further. In the other video which I'm gonna be doing, we will resize the camera, but for now we just have a static width and height, and we won't be changing it further for now. So once we have the size set up, we want to move it. So how do we do this? Basically we just want to check for two variables which I call camera X and camera Y, and these camera values are our tank which we want to follow, and this is just basically its X and Y position. So here we go, X, and analog to that the Y position, and then we want our camera to move according to this one. So how do we do this? We go for the camera set view position, take the camera which we are using here again, because it needs its input the camera and the X and Y position. And once we start it, we will see something which doesn't look good at all. What do I mean by that? So once we started, you see something like this, and you see the tank is on the top left corner, which we definitely don't want to have. So how do we fix this? Basically what you need to know is that our X and Y position always starts at the top left corner where the tank is as well, and we don't want that. So basically we just want to go for the whole width of our camera and divide it by half. So how do we remedy this one? Basically we just go from, what you need to know is that our camera starts at the top left corner, which is 0, 0, and as well we have pinned this one to our tank, and it would go from 0, 0 from the tank as well, and we don't want that. So what we do, we just go the whole camera width and divide it by half and subtract it, so we end in a point over here. So we just go in and subtract half of the width and subtract half of the height of the camera, and this should work. Height, let's check this again. As you can see, it already works, but you see that there's a black area, and if you go back to the map, you see that the camera is trying to follow the tank, but it cannot draw something which is not there, so basically it just goes for a black space. How can we remedy that? We need to do a clamp function, so we clamp between two values, and this is how we do it. So we go clamp and we go for our half value as before, but now we say we don't want to go over the 0 value and we don't want to go over the whole room value. So we go for room width minus camera width, and the same for the Y value here. So we just go in here and say clamp and we go again for a 0 value, room height minus camera show height. So what does this code mean? So basically we just start at this point with the camera always, so it cannot go more to the left, and if the room ends here, we just subtract the width and the height, so we end at this kind of point, so it cannot go further, so it won't go into those outer areas which are black and which cannot be used at all. So let's run it again. So as you can see, those black areas are gone. We cannot go over them. Of course we can go with the player, you can go out of the map, but this is not defined, but this already works. But you may be asking, so where's the difference between this thing and manually doing it with the properties which are already given by GameMaker? Well, first of all, for now there is no difference. This is exactly what GameMaker would be doing per default. But we can do something else. We can apply some scroll speed to it. So how can we do that? That we can do with two additional values which we put in, and they are called current. I have them here, current X and current Y. And here we just go for a linear interpolation, which you will see. So basically what that is, I just copy pasted it so it's faster, you don't have to see me typing stuff. So what are those values? Basically we just grab the X and Y value of the camera, and then we apply some scroll speed and change the position according to it. So we delete this one here, apply a speed value, I call it smooth scrolling speed, and here we apply it to this camera. So how do we do this? We just go for a lerp function, which we just drop in there, and here we just do a linear interpolation between the current position of the camera, then the camera we want to move it to, and apply it with a speed value which we set up here, and the same for the Y value. as well. So we do this, Y and Y. So to explain this code, this is basically the same, but here we have a little change because now it has to play with those two values. To explain this code, we just have our current position and the position to move to, and there we have the 10% value to go to. So we would be scrolling smoother between those values, and there, if you check this out, it will look much smoother. The last thing but not least, we apply on a key which you have to assign later on. Let's go for up and space. If you want to set full screen, we have to check, is the full screen already active? So is it true? Then we deactivate the full screen. We go for window, set full screen to false because we have already full screen. Then we deactivate it, and if that is not the case, we go for an else, and this is the first case. Else, we go for set full screen and set it to true. This is how you would, for example, do a full screen. Windows set full screen. Here. Let's check if this already works. Scrolling is okay too. And this is how it actually works.